The topic is deterioration of highway embankments. Notwithstanding, the new embankment could also be susceptible to flooding, depends on situation or the location or the rainfall. And the climate change and excessive rainfall create flooding, of course, that's very obvious, other than dam failure or infrastructure failure. And the rapid drawdown of flooding creates failure in the embankments. The deterioration model. Do we have any deterioration models? We don't have a deterioration model for embankments as such. We have a deterioration model for pavement, for subgrades, but there is no any conclusive model exists for embankment, for highway embankment itself. So why is deterioration model important? The question is why it is important. The importance of the deterioration model is particularly important for highway agencies because you can address the issue of deterioration, how the embankment gets deteriorate, so that you can know how to ameliorate the problem. Moreover, the geotechnical engineer should know how the deterioration occurs, and the conclusive decision about the root problem should be taken by a geotechnical engineer. So what are the major failures of embankment? The major failures could be bearing capacity failure or slope stability failure, but in vast majority the slope stability failure occur, which are mostly shallow failure. Where is this work applicable? The work is applicable basically for the highway agencies. Of course, it is highway embankment, so it's more applicable to highway agencies. When is this work going to be implemented? That is a good question, but I cannot answer this, but I mean, it could be implemented by highway agency coupled with their own inspection models and criteria, what they are using. But this model further needs development to be implemented into the highway agency. So the aim and objective. The aim is to investigate the deterioration of highway embankments due to flooding in the UK and prepare a deterioration model. Since there is no conclusive model, so I tried to create a model, still further need development. The objectives are to investigate the factors of deterioration from literature review, the study of climate and environmental data, exploration of construction criteria and material, the scrutiny of deteriorated embankment across the UK and highway, investigating HAGDMS reports, which gives you the data for deteriorated sites, and then development of deterioration model accordingly. So the methodology is divided into phase-wise. So the phase 1 is study of relevant literature related to failure modes. The phase 2 is develop and explore the selected asset criteria based on earthwork, ground investigation, geology, and groundwater levels. And then development and creation of deterioration model, which is the important aspect. Phase 3 is identification of deteriorated embankment in highway agency and HAGDMS system. And then find causes of deterioration of embankment and validate the proposed model. Factors of deterioration. So what are the factors basically? There are two kinds of factors. One is internal and the other is external. So the internal factors are geology, poor water pressure, tension cracks, erosion, and the external factors are traffic loading. Of course, the embankment is built for traffic, so the traffic loading is external, and climate and environment, which is rainfall and flooding and weathering, and age, of course, within age deterioration occur. So the criteria of embankment construction are earthwork, which is important for cut and fill. In this case, we have to look into the fill geology in slopes is empirical, and it's important because you need to know the soil condition and the water levels as well are important for design purpose. The design parameters are C and phi dash, which we derive from the soil condition. The existing information, of course, is important because the utility, the telephone and electricity, they are having all the data of old data of the site, so you can get a lot of information from that. And instrumentation records like piezometer, extensometer, if there is any data. The aerial photographs are used these days very extensively, which is very important to assess the slope stability. The construction supervision, which is last but not the least, which is very important during construction. We need to implement the design, so the construction supervision is very imperative. This ground model basically depicts the main features of embankment construction, how the embankment is going to be constructed. So you can see the shed of slump collivium can be detected if you make this model. This model is going to be made by the GI work whatsoever you have done at site. You can know the seepage forces, you can know the piezometer installation, and the water level from the piezometer installation, and of course the C and phi for material property, which is required for design. So flooding in embankment, how the flooding occurs. So there are components of flood risk, which are the source pathway and receptors. The flood impact on embankment is important to be studied, and then method of failure, monitoring of floods, and then flood resilience. So the modes of failure, what are the modes of failure? There are four basic kinds of failures, which are rotational, circular and non-circular, compound, translational, and flows. So you can see in this figure the modes of failure and the basics of the slope. In figure A, you can see the gravity, what is the difference between how the slope failure occurs. You can see in figure A, in the top, if it is gentle slope, the angle is low, the beta is low, and the parallel gravitational force is low, so there will be less occurrence of sliding rather than the down one, which is this one. The gravity will act more than the top one because it is steep. The beta angle is more in the. How do we do a slope stability assessment? We need to estimate the stability of the slope and then select the appropriate analysis after that estimation, which is required at site based on the GI work and based on the material which we get. So the stability analysis has been done by upper bound theorem, limit equilibrium, numerical techniques. But here we are going to take a limit equilibrium method, which is most widely used in the industries. In limit equilibrium, there are ordinary methods, Bishop's simplified, Spencer method, Bishop and Morgenstern, Jumbo's generalized, and Lowe's method. Here, for the rapid drawdown for flooding case, we are going to take Bishop simplified and Bishop and Morgenstern, but the calculation has been done by Bishop and Morgenstern. Stability improvement, how do we improve the stability if any failure occurs due to flooding or any other factor? So there are drainage, we can improve the drainage, the modification of slope geometry, as I mentioned earlier, the gentler the slope, the more stable it is. Notwithstanding, if we don't have a space, then for steep slope also we can do some retaining structures and make it stable. So the proposed framework of this model is identification of weathering types, whether it is physical, chemical, identification of modes of failure, assessment of factor of safety for slope failure, assessment of threshold value of bearing capacity factor, which I've taken as a hypothetical one, the decision making for remediation based on those analyses. So this is a deterioration model. It's a framework basically. We can call it a framework deterioration model where the deterioration process occurs from stable embankment going towards unstable. So to start, I mean, you can see the chemical weathering and physical weathering are the basics which actually affect the deterioration or initiate the deterioration by chemical weathering due to water and mineral, and in physical weathering, settlement and volume change. However, these occur concurrently. They cannot occur single-handedly, like chemical weathering cannot occur single other than physical. They occur both concurrently. So the modes of failure are bearing capacity failure and slope stability failure. The bearing capacity failure, it occurs, which is very seldomly seen, because when you do a site investigation or the ground investigation, you need to first check the ground whether it is suitable to build an embankment or not. And if it is not suitable, then of course you need a remediation for that. For example, if the stress is less than allowable bearing capacity for the embankment, then in the future you can do monitoring. But if stress is exceeding the bearing capacity, then you need to know how the stress is exceeded the allowable bearing capacity. I have proposed threshold values for this bearing capacity calculation, like for getting the stress, strain versus time. And if it is allowable means if it is less than 1, less than this line, less than the dotted line, the threshold value line, it is going to fail, but it is stable, sorry. And if it is exceeding that, then the collapse occurs. For slope stability failure, we have short term, which is total stress, which is during construction, and long term, which is based on effective stress, and that is called embankment, usually taken for long term effective stress, especially for the old embankment and a flooded embankment. So in long term, we take a rapid drawdown case as a long term because the flooding occurs and the failure doesn't occur at that time. It occurs after the water receded from the embankment. So the factor of safety ranges for short term is given 1 to 1.3. If it is below 1, then of course it is near to failure, and then remediation needs to be carried out. And if it is above 1.3, then you can choose appropriate maintenance method if it is at the verge of failure. Otherwise, you can still carry on monitoring. For the long term, the factor of safety range is 1.3 to 1.5. So again, if it is below, you can do remediation. If it is above, however, it is mentioned factor of safety for 1.3 to 1.5, but it can go up to 3. It depends on the slip circle or the location of the slip circle or the location of the weak strata. For getting rate of deterioration, it is a bit cumbersome because rate of deterioration will depend on the age or the time of soil deterioration. So it needs further development for the rate of deterioration to ascertain how the soil will deteriorate with passage of time. So in rapid drawdown case, as you can see, if in figure A, and the poor water pressure, hydrostatic under high water level, if the water outside embankment is up to the level of the crest of embankment is stable at that time. But soon in number 2, as you see, the water level receded. And the factor of safety in B, you can see it goes down straight away as the water level goes down. There is water in the embankment, so there is a load in the embankment. So in 3, you can see the poor water pressure, the transient net, the factor of safety is lower. And then when in 4, it gets in equilibrium stage, the factor of safety are in equilibrium. For rapid drawdown, Morgenstern method was used, but here we are going to use Bishop and Morgenstern method, taking different parameters of height, phi dash, c dash, and gamma. We are using this because here the formula for rapid drawdown is much more suitable to get the factor of safety And we can use the chart, the coefficient, stability coefficient of M and N to get this factor of safety out of the data. So you can see the factor of safety. Here it is for the depth 1 meter, we get 1.38, which is 1.4 approximately. And as the depth goes, the height goes up, the factor of safety increases. So as the embankment goes to high level, the factor of safety increases. So the factor of safety may change during weathering and erosion process. As I said earlier, it is hard to establish factor of safety based on the height only. It may lead to failure because of the triggering factors and rainfall condition. As seen in mudstone, if mudstone is getting wet due to rainfall or water, it is converting towards clay. So that, of course, the strength is decreasing. So the strength is decreasing, the factor of safety will affect it accordingly. In this figure, you can see that the factor of safety has been derived based on the mobilized forces on different slip circles. But then we need to take into consider the change in factor of safety with time as the rainfall occurs, which is the softening of mudstone. As I mentioned, the mudstone will be converted to clay and the strength decrease. So in remediation, we can take remediation action if the flooding occurs. So during stability analysis, the remediation could be stage construction, use of reinforcement, use of pressure berms and vegetation. The HAGDMS, why it is important to mention about HAGDMS, because HAGDMS use a specific format to do the remediation, maintenance of their highway assets. We can use this deterioration model in their structure, but it needs further development to use that model because they are taking only a few parameters to check their embankment. HAGDMS is basically, from the Highway Agency. The Highway Agency issue a quality plan framework for the managing agents. The managing agents basically manage the geotechnical asset, which is the embankment, but they need to apply this. My proposed model, it can be helpful during their maintenance and remediation process and during their analysis of embankment structures and slope stability problem. So overall improvement in the quality assurance system of the Highway Agency. So the case study actually I used for validation of my model. So my model actually, it gives the parameters, and these are some of the pictures. So the conclusion is deterioration model of highway embankment due to flooding was structured in form of framework. It is a process basically, a hypothetical curve model drawn, a model validated through a case study, and then model can be adopted by Highway Agency. So recommendation, the proposed model can be further developed based on deterministic approach of stress, strain, time to failure, because we need to further develop this embankment model. It cannot stand alone because we need to look into consideration, look into different factors. So each factor can have a different model because different soil will be having different permeability. Thank you very much.
Thank you. Okay. Questions, please, on the floor first.
What is the difference between the deterioration and weathering? Between these two?
Weathering is a general phenomena which you can take consideration for basically rocks and soil. Deterioration is process which comes under weathering, which is the deterioration or degradation. So weathering is a general term which we use, but deterioration is specifically for a certain kind of soil, or it comes under weathering basically.
Any more?
Yes, I think I just want to know whether the tension curve will create a deep slope failure or shallow failure.
Oh, that's a good question. Tension cracks, you cannot know from tension cracks whether the slope is deep or shallow. It is basically the weak strata or the location of weak strata which determine the weak zone. So you cannot determine from tension crack. The extent of tension crack you can determine. It's very difficult, although, but you can determine the tension crack extent. But the failure, it's difficult to get from the tension cracks unless you do actually soil investigation at different location and ascertain the weak zone of where where the critical slip surface occurs.
Excuse me, can I follow you up? How would you do it from the tension cracks? How would you make a distinction between the deep and the shallow?
No, I said it's not possible to get weak zone from tension cracks.
Okay.
It is the
Sorry, I thought you
investigation.
were saying that you can separate the shallow and the deep slope phases by looking at the tension crack.
Did
I misunderstood.
No.
It's all right. Okay, there are some questions from my left here or on your right. Godwin? Back.
Go.
Go for it.
Could you tell me what is the implication? You mentioned about weathering.
Yeah.
What is the how the weathering affects the geometry of soil?
The geometry of
Yes.
slope. Oh yeah, that's a good question. As I mentioned earlier in the very first, if the slope is gentle, then the gravitational force is lower, the parallel gravitational force. And if it is steep, then the weathering would occur more. So as erosion and weathering occurs more in the steeper rather than gentler. So that would affect if the geometry of the slope is steeper, the weathering would be more rather than the gentler.
Okay, now the factor of safety changes with time. Where is slope and then with time, the factor of safety changes. Maybe there is evolution of whatever. Does it change?
The factor of safety.
Yes, it seems to show diagram
Oh yeah.
take place also.
You mean
the factor of safety?
yeah.
Yeah.
Due to heavy rainfall, as I mentioned, the mudstone will convert into clay. As every hard rock which is susceptible to weathering, it will get deteriorated and it gets softened with time, with weathering
How
and
do you
water.
show that the slope still is stable and there is stability in your design?
Yeah.
Considering the time, it will. So
Yeah, that's what actually I put in recommendation that further research needs to be done to ascertain the strength parameters and calculate the strength parameters for different kind of soils, and that need actually further work to demonstrate which kind of soil deteriorate in how much time. That's why the different embankments are built with different kind of soil. In the UK, actually, most of the soils, most of the embankments are built by clay soils. So I think, again, it needs further development for the clay, a different kind of clay like Gaul clay, London clay, which exhibit actually a deterioration with time, like 10 years, 20 years, and then you can take into consideration that and accordingly apply to get the factor of safety, a conservative factor of safety.
and also somewhere, I think you mentioned the failure, and you talk about the bearing capacity failure, and then you talk about this, the
Slope
stability. Yeah, so can you from the
Well, I mentioned here.
no, I think there's diagram.
Okay. This one.
Mm-hmm.
No, there is no diagram for bearing
No
capacity.
diagram, but you mentioned about the bearing capacity, and then you talk about, you give a solution of drainage, you say drainage, and then retaining wall.
Okay.
And that's it.
Okay. Yeah.
Well, you can't open the floor, I'm not sure.
Oh, okay. You
You
want the
show
figure.
drainage as well. You mentioned drainage, you mentioned the retaining wall, and what as solutions to
Remediation solution. You mean?
Mm.
Yeah, I've given it here. The stability improvement.
What Okay, I think that's fine.
I haven't given the figure for that
No,
because
you need to know, but
the time is short and I cannot give a lot of pictures. But yeah, I mean, you
I'm
need
fine.
further ask any question? Like, I mean, I can show you if
No, I'm fine, I think I can't go.
Okay.
Okay.
Would you like to?
Yes. Can I have a point of clarification? Is the focus flooding?
the focus is deterioration model basically.
Yes, but up there you've got flooding.
Yeah, but it is particularly due to flooding.
Okay.
Deterioration model.
When at the embankment of a road and there's a flooding event, which way does the water go?
Down slope.
So you've got an embankment on a road,
Yeah.
yeah, and there's an embankment, and it's flooded.
Yeah.
What's happening to the water?
What's happening to the water? The water will be there until,
I mean, I'm trying to understand what because you've done flooding as a rapid drawdown.
yeah,
There are, to me, there'll be situations which are rapid rise.
you
You see, you're just focused on rapid drawdown.
mean in this one?
You've gone rapid drawdown,
Yeah.
but if you've got an embankment and there's a flood event, the water level tends to rise and it floods the embankment,
Yeah.
which is the opposite.
Yeah, but we are trying to say the failure occurring due to rapid drawdown.
Right, that's the point I'm coming to. If there's a flooding event, there's a rise, what other failure mechanisms would we need to consider?
When the water level rises.
Yeah, you've got something there's a flood,
Yes.
and it's built up over a few hours. Yeah, the water level's down. We've seen pictures of it all around the country. The M5 was flooded.
Yeah.
It wasn't a rapid drawdown, yet the water rose. What's the failure mechanism involved then, other than after the event?
After the event.
Yeah, when the floods subside, there's a drawdown, I agree, but there's a rise in water, what else can happen?
So your question is when the water level water goes down,
No.
or when the water is there,
When the flood starts,
when the
during
flood starts.
yeah,
Yeah.
what can happen? There's been cases of it.
Well, failure of embankment, of course. I mean, and then you mean other failures.
Yeah.
Other failures could be the impact of flood or the
Yeah.
soil which is laden in the water. It will impact the structures like concrete, embankment, whatever.
Okay, erosion is what I'm.
Yeah, that's what I said. I mean,
yeah,
this-
okay.
The other soil will come and it will erode
And there'll be
everything. It
cases
will take
where-
away everything with
And
it.
if there's a flow, it can
Yeah.
undermine the embankment, and the embankment actually collapses during the flood water rather than post-flood water.
Yeah,
You focus on post-flood water.
yeah,
Yeah. There are other cases, that's all.
yeah. That's why actually, if you can see here, the erosion will occur here, which is very obvious. But the failure would occur in a large extent if there is like a rapid drawdown and then
Right.
there
What I'm
is a-
drawing to is rapid drawdown's fine, but there are other deterioration situations. The classic on YouTube footage, which I think, anyway, I'm Dr. Ken Dormer showing, a railway embankment in Canada, and as water level rises,
Yeah.
it completely
It
erodes
completely
it.
eroded
And
everything.
the guy goes, oh poo, and has to run, hightail it out there before he gets drawn into the water.
Exactly. Yeah.
Yeah.
So it's erosion, of course. With flooded erosion is a normal phenomenon.
What other failures might occur? And we looked at
Burrowing,
No, no, no.
erosion failure.
Hang on, let me just finish. We talked about bearing capacity failure, we talked about settlement, and now erosion. And one gets the impression we're looking at the macro scale as a whole embankment going down. But what other things might happen if the embankment floods? Remember, it's carrying a road.
You mean to the whole embankment or?
Well, to its functional requirements.
Well, there will be, for example, if there is a bearing capacity failure because of foundation and
Those aside,
slope stability failure, and then the road itself,
yeah.
the concrete will deteriorate.
But if it's a flexible road as the type you've shown there on the right,
Yeah.
with a barrier, what would happen? Or what might happen?
You mean for this kind of road?
Yeah.
I mean, if it goes further more down, then of course there is an impact of water for the subbase. And then if there is a weaker zone below subbase, and if the water was standing for a long time, then of course it is deteriorating in this berm, and then eventually this, the whole road will get failed.
Okay, let me ask you another question. You showed an example. I couldn't quite see the calculations you've done. Can you put some slides just to talk us through the numbers? There you go. Leave it there. You've chosen this as a case study, I presume.
I've just taken it as an example, yeah.
As an example. So you've got 27.5 degrees. This is highly accurate. We'd never be able to determine that in the lab.
Because I want you to come to the stability, I want you to use the stability coefficient actually. You can see the 27.55 dash is given here, so that's why I wanted to use this 27.5.
Okay.
That's why I used it. So I could use like anyone, 25, 22.5.
So can you go back again to the other slide? You've got RE of 0.25. Is that reasonable for rapid drawdown?
This is a weighted average value, but for rapid drawdown, it's been taken for the point, the phreatic level.
Yes, but you've got water high in the embankment.
Yeah.
So is that a reasonable value to take?
Well, I've taken this as an example, not in fact for the...
Is that from a publication somewhere?
Yeah, this is from the publication, yes.
Okay. Okay, any more questions? Last questions? Right, no more, so thank you very much. Sorry.
I was just going to ask, I can see how applying the deterioration model to a newly constructed embankment will work. How would it be applied to an existing embankment? How do you know how far down the weathering cycle you are and how much it's deteriorated?
Well,
when you come to it?
That's the maintenance actually. Basically, HAGDMS is doing Highway Agency Geotechnical Database Management. They have actually, for each and every embankment in the UK, they have a data for each embankment, which is in the HAGDMS system, which is online system. So all those embankments, old or new, they are maintaining it and they are inputting the data. They are inspecting like yearly, 5 yearly, and they are inputting the data into the HAGDMS system. And then from HAGDMS system, you can retrieve the data for any embankment wherever you want. And then, I mean, they have, actually, Highway Agency has a hired managing agents. So they're doing those maintenance and remediation for that.
Okay, thank you very much.
Thank you very much. Thanks all.